Getting started with OcfAPI by Objectis. In this video, we're gonna learn how to use OcfAPI in .NET applications. We're gonna create an OCF server in a simple .NET sine wave generator. There are two demo applications you need to download on our website. The first one is the server, and the second is the client. We're gonna start with the server. It's a very small application, and with just a few lines, we'll see how you can benefit from the power of OcfAPI. When we open the project, we see that a generator class is already there, and we just need to complete the main function of our application. We start by creating an instance of a fast native UDP OCF server. This only requires one call. We create a variable of type OcfAPI server, call the function createOcfNativeUDPServer, and specify the port to be 10,000, while the root object is my generator, the generator we just created. You can specify any variable as the root object. OcfAPI uses reflection in the .NET framework to automatically discover the model of your application and make them accessible via OCF. Now, we need to go into a loop and periodically call the run function of our generator. The run function makes the signal value variable change with time. We finish by executing the OCF server periodically. We use the execute OCF server function and pass it our server variable. This will make the entire structure of our generator available through OCF. And now we can run our application and launch live tuning to see our generator run. We create a new fast native UDP connection and see that our sine wave generator shows up in the tree structure. Let's get to work on the client. Open the OcfAPI Client HMI demo. It contains a simple window with a text box, a button, and a slider. We're gonna make it interact with our server. We first need to go into the code behind file to create our client. So double-click on mainwindow.xaml.cs on the right. OcfAPI uses the dynamic type in C#. This means we can access any member of our object at runtime. A dynamic public property called client is already declared above. We just need to create the connection. Client is the variable we'll be able to inspect remotely. Earlier, we created a fast native UDP server. This is why we're creating an OCF native UDP client. The hostname is our loopback address, and the port we specified was 10,000. Now we can go back to the view. We want to display the signal value when we click the Get button. So we double-click the Get button to create a new click event. The text box is called Signal Value Text Box, so we write signalValueTextBox.text equal client.signalValue. Communicating with OcfAPI is completely transparent. We use the client variable as if it were a local variable. This makes it very intuitive to communicate with our server. We want the slider to update the amplitude of our signal. We're gonna do that using bindings in the .NET framework. When we bind to OcfAPI clients, we need to create a public property to make sure the types are converted correctly. So we create one for the signal's amplitude above our main function. Get simply returns the amplitude on the client, while set simply sets the amplitude on our client. We're going to create the binding to our amplitude property. This is very easy to do in the XAML of our view. So we switch back to the view and bind the value of our slider to the amplitude property we just created. The binding will make it so when we launch our app, the slider will reflect the value of the amplitude of our server. It will also make a change when we move the slider. Now, you can run the two applications at the same time. When we click the button, we get the current signal value. When we move the slider, we directly modify the amplitude. We can verify this by clicking the button again and seeing that the amplitude is greater. It only took us a few lines of code and a few minutes to implement OcfAPI. We hope you'll give it a try in your own projects.